How do you effectively tune hyperparameters for regression models? Imagine trying to tune a musical instrument without knowing which strings to tighten or loosen. That's similar to adjusting hyperparameters in regression models. It's all about finding the right settings to make your model perform its best on new data. Hyperparameter tuning is the process of choosing the best set of parameters that are set before training begins. These parameters control how the model learns and how well it predicts. When done correctly, it boosts accuracy, helps the model generalize better, and makes it more reliable. First, you need to understand which hyperparameters matter most for your regression model. For example, in linear regression, you might focus on regularization parameters to prevent overfitting. In decision tree regression, tree depth and minimum samples per leaf are key. For support vector regression, kernel type and regularization strength are important. Knowing what influences your model helps you focus your tuning efforts. Next, select a search strategy to explore different hyperparameter combinations. GridSearch tries every possible combination from a predefined list. It's thorough but can take a lot of time, especially with many hyperparameters. Random search picks combinations randomly within specified ranges. It's faster and often finds good settings with less computation. Bayesian optimization uses probability models to predict promising hyperparameters and refines the search based on previous results. This method is efficient for complex models and larger hyperparameter spaces. After choosing a search method, define how you will measure success. For regression, common metrics include mean squared error and R-squared. These tell you how close your predictions are to actual values. Use cross-validation to test how well your model performs on unseen data. This helps prevent overfitting during the tuning process. Now, use automation tools to run your search. Libraries like scikit-learn offer GridSearchCV and RandomizedSearchCV, which automate testing different hyperparameters and evaluating results. More advanced tools like Hyperopt can implement Bayesian optimization. These tools save time and reduce manual work. Once the search is complete, compare the models based on your chosen metric. Select the hyperparameters that give the best balance between accuracy and simplicity. Remember, a more complex model isn't always better if it overfits. Finally, keep practical constraints in mind. Tuning can require significant computational resources and time. Also, be cautious about overfitting to your validation data. It's important to maintain fairness and avoid bias in your models. In supervised learning for regression, hyperparameter tuning is a vital step to improve how well your model predicts continuous outcomes like sales, temperatures, or house prices. Using tools like ChatGPT or productivity plugins can help generate code snippets or explanations to make this process smoother. While models like DALL-E or Midjourney are mainly for images, they show how tuning hyperparameters is essential across different AI tasks. In short, tuning hyperparameters for regression models involves understanding which settings matter, choosing a smart search method, evaluating with proper metrics, and using automation tools to find the best combination. Doing this carefully helps create models that are accurate, reliable, and ready to perform well on new data.